Okay, got it. All right. Okay. Well, all right. My name is Eric Horn. I'm the managing partner of Element Consulting. And so this is just a really great topic that we're going to be talking about today. I get asked about this kind of stuff all the time, especially with the emergence of AI and how that works with PLM and all of your enterprise applications like ERP, MES. And so, really, today we're going to be talking about how we go from engineering to execution and how the whole digital thread plays into that with PLM, NPM, the digital thread that drives autonomous operations. Now, you're kind of probably thinking autonomous operations. Well, what does that mean? Well, we'll kind of get into that. And I think the end goal is that everybody wants to automate their systems and their processes. Well, what does it take to actually get there? How far can we go? Are we ready for it? All great questions. We'll be talking about that throughout this presentation. Won't really get into too much about Element at a glance here, but essentially this says is that we've been around, we've done a lot of projects. Pretty much most of our work comes from referrals, which means that we do good work, and that means we get recommended to other clients and do good work for them as well. We do also much more than PLM. So it's all about the digital thread. How does it fit in? We are great at, of course, speaking PLM. Windchill is the core. It connects to all kinds of systems, especially if you use that for your digital thread. It can start all the way up in the sales system, which is CPQ. The orders can come into Windchill. If you don't have that, then Windchill can just talk to your downstream systems like ERP, MES. Is there anything else that you have? Some people have homegrown systems, quality management systems, training systems, whatever the systems might be. But at the root core, these are the main enterprise level systems that they should connect to. And then that will help you then automate not just your systems, but your processes across these. And so it's really important that you take a look at, am I connecting these systems? Do they talk to each other? Where is the boundary for the business process across these? And are we actually optimizing for process throughout the systems? Because if you're not doing that, then you're not taking advantage of the power of PLM, Windchill, and all these other systems. And you will reap the benefits once you start going down this path. And that's kind of where the root of this conversation is going to be leading into. And so with that, people, process, and technology all have to work together. And you're like, well, why is that? Well, because people are the ones doing the work. They are the ones with the knowledge. They're the ones doing the clicks. And then what happens is they are facilitating some sort of process within those systems that they're doing, whether it's I'm designing a part and I need to release that for production. They could be, doing all other kinds of things, requesting quotes for new parts to be introduced to the system. Maybe you have component engineers, you have manufacturing engineers coming in the system that then need to do something with the design. They got to create a bill of material. That bill of material then must go to ERP. There's many different processes that they're doing. So need to focus on those people side of things, especially then the process. And that process should not just be within the scope of Windchill, but the process end to end. And then lastly, technology. So the technology will be there, but that's kind of the easy part of the equation. If you're using a modern system, but you haven't changed your process in the last 40 years, then I think you then need to take a look at your business process and your people and how you're going to use that modern technology to now optimize your business so that you can utilize AI, you can automate processes, you can assist them in the process. There's many different things that you can do. All of these have to work together. And so you really can't work on one part without the other. And so that's kind of where we get today to look at engineering to execution. Why is this important? Why does it matter? How can we use these systems? And so you're like, okay, so engineering to execution. Well, what does that mean? Well, what strategic initiatives do you have this year? I guarantee you a lot of those strategic initiatives is somehow talking to, we need critical systems or business practices to lean out manufacturing. We need to be more cost competitive than ever. We have to be faster to market. We need to be using modern technologies on the shop floor. And guess what? Those modern technologies on the shop floor need to be fed from modern technology upstream that are now communicating with those. And then with all this too, we're also being asked, our companies are being asked to meet increasingly more complex products, the demands of the customer, demands of the market, whatever it might be. And so with that complexity now comes a lot of traceability as well. And so if you're in a regulated market like, say, med device, aerospace and defense, those are really highly regulated, being pushed to do more with their systems. So these regulatory bodies are always coming in. Do you have a digital thread? We need to ensure high quality, high rigor. And so you have to be using these systems and use them so you can be able to trace the genealogy of your product data, how that then feeds into the requirements, and then how those requirements are met by the shop floor, and how do you know that the parts are being built correctly to spec and to the requirement. We also need to take a look at, well, how do we break the IT and OT silos? And so this is kind of the whole difference between kind of the IT side of things and the operational side of things. And so we kind of need to break that down, is how do we have integration between the data and the shop floor systems so that you can pass information downstream without having to break what we call the digital thread. And I know sometimes these words can actually, and you can get a little too over familiar with them to the point like, okay, it's just another industry term. But yes, it is very critical that you take a look at your digital thread, which means how my systems are connected and how the data is flowing. And of course, we also talk about this enterprise orchestration layer, and that enterprise orchestration layer is really the way that data is being passed between systems and how they're integrated. So all those are very important. And so we did touch on the digital thread. Well, why is it important? Why are we taking a look at this? Well, it's because you have data. That data has a life cycle. It needs to move. When certain things happen to the data as it matures, what happens to it? Well, the digital thread needs to know and understand that, because as you, say, get something ready for your first NPI, your new product introduction, well, it then must flow somewhere and do something. Maybe you have a mature product that is getting released for production. Well, that then also needs to do something in your ERP systems, and maybe those data need to be treated differently because they are different. Then also you look at the data propagation. So when we do mature that data, how is that propagated? You need to make sure you have the right triggers in place so that the right data gets passed. And this all goes into the importance of the digital thread, because what you don't want is all that to be stuck in a Excel spreadsheet somewhere, and then lo and behold, nobody knows the actual status. Why is it not there? Is it on order? All that information is extremely important. And then all this then lays down the foundation of, well, AI and analytics. So if you want to get to using AI intelligently within your company, well, you kind of need that good foundation of data and process in the system, and then it can help automate for you. You can't just tell AI, hey, go clean up the data for me. It's essentially, right now, it's at best at like a junior researcher. So it can help you analyze the data and try to help clean it up. But guess what? It will be very confident in a wrong answer. So you need to make sure that you clean that up so that you have the right answer to start with, and then AI can then do wonders because it has a good foundation and can make good predictions off of your data. And then what does that do? Then that means that you're going to have improved manufacturing outcomes because you have enabled your systems to have clean data, or maybe mostly clean data. You've gotten your processes down, your digital thread is connected, data is flowing down, and then now that means that manufacturing is getting the latest information, which also means that maybe you could reduce that cost of poor quality metric on your shop floor. So you can really reduce the amount of manufacturing defects because you are manufacturing to the latest information. And if there is a problem, guess what? That data can flow back upstream, send a change downstream to the systems, and then you can be manufacturing to a better new state so that way you can increase quality in your products and do that faster before your customer realizes there's a problem. That's always the key thing. Make sure your customer doesn't find the problem. You want to find the problem first. Then once you find the problem, don't pass that on to the customer. So then you're like, well, why is Windchill so important? So a PLM system is really the core of where all the data starts. That's where all of your intellectual property is stored. That's where engineering is doing their work. PLM is not really a data repository just for engineering. While it can do that, it can do so much more. And then if you are just using it as a repository, well, guess what? You're losing out on a lot of benefit to the organization. So PLM has evolved over time. It used to be relatively what we call PDM. And PDM is for product data management storage. And PLM is really now how do we facilitate process across the enterprise with breaking down silos between engineering, manufacturing, and then really facilitating process as that data matures. It also, of course, it unifies data and governance. So that data and governance is very important because you want to make sure that you get the right approvals, everything is tracked and traced, is your data linked correctly? Very, very important, because what happens is as you make a change to something, what's usually the first thing people want to do? That's right, they want to do an impact analysis. Well, in order to do an impact analysis correctly, guess what? Your data should probably be linked together. That says that if I change this part, I must also change these 3 specifications. Or maybe I don't. Maybe I don't need to change those 3 specifications, but I need to at least look at them to see if there is a change required. Or what also happens more frequently is that I have a specification change. Well, what parts reference that specification? How do you know that? Well, a lot of times people are like, well, I now have to search through all of my engineering documentation because since the data is not linked, I now have to manually check that. Well, guess what? That can take hours, weeks, months. I don't know how long that's going to take. It depends on the size of your product data. But guess what? If you're using PLM correctly, you should know that just by looking at a simple screen and saying, if I change this specification, these 30 parts need to be investigated. There you go. There's your impact analysis. Now, of course, the impact analysis needs to go deeper than that, but that is at least a start, and that's a really quick start. So, and then with that too, then PLM should now be integrated. So this integration should happen across the systems. So usually the 2 core ones is into your ERP, because that is where not only do you procure materials, so you want the bill of material in there so that you can procure the right parts, but also if you're manufacturing, well, guess what? Work orders need to be executed within ERP. And if you're mature enough and have some complexity, you probably also need an MES system. A lot of companies have a homegrown system, just fine. At least you're using some sort of manufacturing execution system in there. But so the data needs to flow in those, because then ERP then needs to open a work order within MES, and then now you can facilitate manufacturing. Some companies do contract manufacturing, which then means that either your ERP or your PLM needs to provide a package to your actual manufacturer of the source, the truth of that data. Well, guess what? If you're using the PLM system correctly, you're pretty darn right that you're going to get a package that contract manufacturer can build. But if you're not, and you're not linking the data appropriately, you're just relying on somebody to put together the right package for your contract manufacturer to make sure that they're producing the right thing. So that opens you up to risk. So make sure you're also, that's another problem that you need to make sure you're tracking and solving. And then, of course, it supports global complexity. So if you are a global company, many divisions, and you need to collaborate together, PLM is the perfect way of doing that. So you can do that not just in engineering, but you can also do that across your manufacturing. You can facilitate building parts in different plants, facilitating all kinds of supply chain scenarios. And that way you can, then if there is a change, well, guess what? You can now check that ripple across not just your engineering department, but your manufacturing departments, and maybe even down to the facilities and plants that are actually manufacturing. Really powerful, really great tools. All right, so we're going to dive in now. We covered the general overview, so we're going to dive in a little bit more. Well, what does this actually mean on the digital thread? Well, digital thread here is kind of like, this is how like manufacturing process, which we usually call MPM for manufacturing process management. So this is how you take that engineering data and flow it into execution, which is your ERP and your MES, so that now they can produce it. So what that means is I have these engineering BOMs, which are usually built from your engineering data, your CAD, and then that goes into, we'll just call that the MPM engine. It's really not an engine right now. It's probably somebody dragging and dropping things. If you can automate it, sure, there are ways that you can automate it. But then what then happens is that you use that to transform your EBOM into your MBOM. And then guess what? You can now plan as well within PLM. And so you can make the process plans, and then those can be plant specific, or they can be generic and not plant specific. And then those plans can then be fed into your ERP and your MES. And so this is kind of how that data flows and then down into your downstream systems. And guess what then that gets you? It gets you all of these improvements over here on the right hand side. So you get this faster wrap up time, because guess what? The data is flowing faster. You no longer have to throw it over the wall and then have everybody do that in Excel spreadsheets or however else they do it, store it on share drives and do the manufacturing side of things. All this collaboration is happening inside of PLM. You get improved quality. So you may say, well, how does that improve quality? Well, what happens is that you're kind of forcing the departments to work together collaboratively, because if you've designed it appropriately, this little cycle here kind of happens before it actually hits the shop floor, and hopefully even before engineering has released the first revision for production. And so then you're getting the eyes on it, so people are getting to see that earlier, and then they're correcting mistakes before it actually even gets produced for the first time. And a little quick metric for you: have you ever seen an 80% reduction in cost of poor quality? I have, and that's because of this. So manufacturing was able to catch all the mistakes earlier. So it used to be before, they were like, oh no, they're catching all the mistakes on the shop floor, writing non-conformances, sending them back to engineering, doing about 400 of those a year. Well, guess what? After doing this kind of process and having their eyes on the data before it hits the shop floor, they reduce that 400 count over a year to about 40 per year. That's a really significant drop. Imagine if you replicate that across your business. How can that not only get you faster to market, reduce cost of poor quality, and which, of course, if you're reducing that cost of poor quality, that means you're making more money, which means you can either pass that on as profit to the company, or you can actually reduce cost of your product, which means that you then pass that cost savings on to your customer, which may also be a competitive advantage, and now you can sell cheaper, better product to your customers. Agile change management. Agile change management is great, because then what happens is all this essentially analysis can be done up front, because the data is kind of integrated already. So now you can say, hey, I'm going to make a change to something. Engineering no longer has to pick up the phone and call manufacturing. They can actually say, hey, we all are collaborating in the same system, and then we can actually work on the changes together and understand the impacts all together at the same time. So I can get much more longer into this, but those are just real quick, the benefits of MPM and the old digital thread. And so with this then comes in that whole process of continuous data flow. So the continuous data flow means as it matures within PLM, that then will flow downstream. And guess what? If you do get that quality process that says, hey, there's a problem, there's a non-conformance, it can send it back upstream and kind of have this continuous flow of data back. And so you can build that in many different ways. You got this whole traceability and feedback, a closed loop feedback system for product design, which now means like as you either manufacture it or maybe even as you service this in the field, you can get data back and actually start saying, I'm going to start logging problem reports against the engineering. And then now you get this traceability and trackability of these problems that are coming in, and then actually how you resolve those and then fix those into new product. And then of course you can kind of see there's all these compounding value that you get to the business. You can connect more data and you can start increasing the value to the business. You can get more insight and better operational speed because you can react with actual true data. It's no longer just this guess analysis that I usually say that a lot of companies do. So it takes a lot of time to get there, but once you start doing this continuous data flow, that value will come. It allows you to do better analytics so that you can now do better prediction about where the company needs to go and get that increasing that operational speed, because now you can react faster to the market too. So you can see like, hey, there's a shift in demand saying like, I need to go from, burning gas to electric power. Well, we can see that. We can send a signal to engineering. Guess what? They can change the design, send it through manufacturing. Guess what? Hopefully that means that we can get the new product out the door quickly. Then you also get this technical and operational mindset. So this is really more than just a technology push, because as we're talking through this, guess what? Your business process has to change. So that's why the technology must go with the business process, because that is where it's going to hit your company in the operational side of things. And so you really need to get into that mindset of what's this going to do to me? How does my process need to evolve? I can't keep doing things the way I've always done it, because I will never improve if I don't change the way I currently do my business process. So then we get into the whole orchestrating manufacturing and how do we use NPM. And this just is like diving even deeper into that NPM kind of bucket. It says, hey, here's all the data that kind of goes into the system. We've got all this engineering data. It's got CAD, it's got bills of material. Then we got this manufacturing data that all needs to go in there. We have BOMs. We need to create process plans so that we can execute and create the routings in ERP. Then everything is version controlled. We have this data management and governance over everything. And then we want integration to the downstream systems. So that's where you see all of this is happening inside Windchill with NPM, and then it flows downstream and then goes into your ERP and your MES. And then now you can then manage all of this kind of data. So you've got in ERP and MES, your order management, inventory control, production scheduling. You've got work instructions, machines connected that are collecting data and saying, is my products within specification? We have quality control that's doing inspections and then putting buy-offs on things saying, yep, I have my stamp of approval. Quality inspector number 3 approved this. You got real-time execution data that says, how's the shop floor doing? All of this then connects together and can really, give you that result of, hey, I can now be on time, I can be highly accurate in my manufacturing system. So all this is great. You're like, okay, well, what are the other things I've heard about? Well, now we talk about there's this big push for AI, digital twins, autonomous operations. Well, guess what? If you haven't done any of the stuff that I just talked about before, a lot of this stuff won't just appear overnight. So you're like, what I need to do as a business is I need to connect the data, have my silos of business like engineering and manufacturing, supply chain, all working together, hopefully on either a single system or on a digital thread of systems, so that way I can now enable this technology, which means like, hey, I want to now allow AI to help me orchestrate, because it can do things like help me do impact analysis, and it can do it in an automated fashion, and maybe it can do it much quicker than a human, so that way I can say, hey, I have this change coming up. Can you give me an estimate to say, what is the impact? How much time is this going to take? And when is it going to be able to hit the shop floor? It'll be able to do analysis for you. Maybe even say, hey, Eric, not only is this going to take you 3 weeks to do it, but if I send this, downstream, I can help you make the rev changes. As we do the rev changes, I can then also maybe do most of your automated checks for you, so that doc control can pass it quickly, and then maybe we could reduce that time from 3 weeks to, say, 2 weeks. And then now you're using AI to help you empower your company to make faster decisions and do the data work faster for you. And then, of course, along with AI, I always hear digital twins. Digital twins is very powerful, but only if you actually need it. So, and a lot of people get confused. Well, what does the digital twin actually mean? Well, a lot of times it is kind of like a serialized version of a product. That's usually what we think of a digital twin. Or sometimes it can even be a twin of your process. But here, what we're kind of using the digital twin for is to help you do simulation. And some of that may come in the form of, getting that serialized version of the product or the full 3D capabilities of it so that we can do a simulation against that. Or maybe you can actually run that against your process plan. Your process plan is the bill of process for your manufacturing, and it can also, that's also a digital twin of what's happening on the shop floor, and we can do analysis on that as well. So be really careful though when people do talk about the digital twin, because there is a lot of misconceptions with that terminology, and so you have to be really clear with what are they actually talking about when they talk about the digital twin. So then this importance of a digital backbone, this is really important. So you need to make sure that engineering and manufacturing is really tight together, because you need to have that really well defined for AI to have initiatives to be more than just experimental kind of functionality to help you improve in this area. Your teams must be working together inside the system so that it can understand how both behave, and the data should be clean so that it knows how the data is linked together. Notice how I keep kind of mentioning data being linked together. Very important. If your data is not linked, that is kind of like the core basis of where you should be in order to enable AI within your business to get to this autonomous operation capability. And so then we talk about the foundation for advanced automation. Well, organizations that are investing in this can adopt this if they have done what I just described, is that you need to leverage that foundation. That foundation will then enable your AI to give you accurate results, not just be really confident in a bad answer. And so that's really where you need to ask it is, how do I get to make sure that AI can give me a really good answer as quickly as possible? So now we're diving deep. Well, how can AI help? Well, metrics. So usually most companies, if you are good, are probably tracking some sort of metric. And so these are just some very basic metrics that a lot of companies will do. And sometimes I have to say, well, maybe they're not so basic, because most companies try to track these and do a really bad job. And so cost of poor quality is one that I've talked about before. That's kind of like, that's essentially trying to measure, well, when I have a quality miss on the shop floor, how much is that costing the company in time or monetary value? And usually the higher the number, the worse off you are. So you're always trying to reduce cost of poor quality to make sure that you are not burdening the company with too much extra above and beyond cost. Operational equipment effectiveness is also one that a lot of people tend to throw out. I'm not a big fan of this because most people just measure uptime of a system or uptime of a piece of equipment. Is that really measuring a whole lot? Probably not. And so this is also why it's not used very often, but it can be powerful if it's tracked appropriately and should usually go along with some other metrics. On time in full. This is a great metric because you don't just want to be on time, because some people have this whole, a moving gate of what on time means, because sometimes like, well, initially we quoted the customer 3 weeks. The 3 weeks came up and said, hey, customer, we're having a problem. We're going to renegotiate for what on time means and put out another 2 weeks, which then that means is that my on time in full usually doesn't really track very well because you keep moving the goalpost. But in full is important because you want to know not only am I on time, but did I give them all the units they asked for? I didn't short them. I didn't give them half the order because I couldn't produce enough on time. So usually tracking on time in full can be a very powerful metric too, to let you know, is manufacturing actually meeting the dates that they are saying. Cost per unit is also really important, because how do I track if I'm actually making margin? Every company tracks profitability by margin analysis. And so your cost per unit will help you get there. Safety incident rate is also one that's really good. Most companies love to have a high safety culture. You need to make sure that not only are you producing good product on time, but that your people are also doing it without getting injured and they need to go home at the end of the day. That's always very, very important. And so you're like, okay, so you're saying, how can AI help in this area? Well, guess what? It's great at data analytics. What's behind metrics? You got it. It's data. So what you can then do is you can say, hey, AI, I want to reduce or increase whatever. I want to improve one of these metrics. Can you tell me how? And guess what? If your data and your systems are accurate, it might be able to say, well, sir, you can improve metrics by if you actually had a faster close time of your ECNs so that when there's a quality defect, engineering, the faster they close them, guess what? The faster you're making better product and you'll reduce cost of poor quality. So it can take a look at some of that. Or it may actually spot like, hey, maybe you don't have a problem in engineering. Maybe your problem is manufacturing. It says, hey, you know what? Most of your quality defects come from line A. And on line A, most of those quality defects are coming from a quality inspection gauge. Maybe you should go check that to see, is it actually a product problem or is it an inspection problem? I don't know, but it's hard to guess where AI can help, but it's really good at analyzing the data, assuming it can actually track them. And so that then goes into, hey, AI is going to need this orchestration layer because guess what? It's not going to be very powerful if it's only connected inside one system. An AI layer is going to help you when you connect it to all of your connected digital thread systems, because as the data is linked together, as you are moving data across your systems in this continuous flow, and you even need to start with continuous flow, at least get it flowing in one direction and then get the bidirectional at some other time. But once you start doing this, now it can actually make sense out of it. It's like, oh, hey, it's like I need to go from Chicago to New York. Well, what do? You pull up a map. You can see how the cities are connected. Well, AI needs to see how your data is connected, and now it can make sense out of your data and know how to get from point A to point B when you ask it a question. That's thought-provoking. So don't really think of this as a lot of this is a technology problem, but it's also a big people and process problem. And if you think this is going to be solved just by implementation of technology, you're going to be severely wrong. So if you're not investing in your people and your processes, then this will not be successful, because guess what? At the core of this, we have engineering connected to manufacturing, which is connected to process plans, which is then connected to my downstream systems. Now, does it always have to work in this way? Not necessarily. You can skip doing process plans for now. Maybe you need to start basic and say, I'm just going to do an EBOM to MBOM, send that to my ERP. That's a fantastic start. And then after you do that and you get comfortable with that, guess what? You're going to be looking for other areas of improvement. As you start using AI maybe to help you with your bill of material, you say, hey, we're going to start investing more into process planning. And maybe we need to invest into an MES. So there's ways to stagger it in, but how do you know what's right for you? What's going to get you the best bang for your buck? Well, usually starting at the core first with your engineering data is always going to be beneficial, and then keep following the process and improve it. And if you need help in that area, guess what? That's what Element Consulting is here to help. So that kind of leads us in, how can you get there? Well, I'm a big advocate for roadmaps. And roadmaps can really help you in determining, hey, what are my short-term focus areas where I need to improve now? What are my midterm integrations that I then need to focus on? So I'm going to kind of clean up the data. I want to start integrating the data. And then guess what? Once I start getting that process flowing, I can now take a look at my long-term vision. Maybe I need to see about how I manage my electrical CAD, and not just that, the electrical bills of material, because guess what? They're a lot more complicated than a mechanical bill of material, because you have a lot of different suppliers, preferred, vendors for certain parts, and it always changes. And you have to do what we call an AML and AVL. That may be a long-term vision. Maybe you then want to say, okay, well now how can AI then fit into my long-term vision and start helping me orchestrate, or at least maybe actually analyze my data and help me do a better job and do a faster job at some of these things, so that, say, ECNs don't get stuck, waiting 3 months to get solved. There's not this 2-month approval cycle. And AI can say, hey, I know how to bug people to get things approved faster so that they're not waiting on somebody's signature to review. Because guess what? Not only can it help you know who's the roadblocks and notify them, it could probably also tell that person maybe what they need to know about the change, because the reason they're not signing the change is because they don't understand it. And then so with that too, so you take a look at the short-term focus areas, improve on that, do the integration, whatever else needs to be midterm. And then you want to take a look at what's the long-term roadmap. And now, of course, look at the success factors that you need to do to actually make this the thing. Don't think that this is just a project that needs to be done in a silo. Your executive sponsorships need to be bought in on this. It's very important that they are aware, being communicative about it, tell you what metrics there is important to them. Because guess what? If you're making changes and you're not moving the needle for the company in the right metric, well, your project may be canceled. So make sure you're focusing on those metrics that the stakeholders are going to be actually responding to. And then, of course, you want this continuous change management in there. And the continuous change management means I need to adapt my people, process, and technology as the company's priorities shift. So, and that always happens, is that there's always going to be market demands that are changing. Things are going to come up when the company needs to pivot into a new product area, or maybe they need to innovate. So you need to make sure that whatever you're doing now, that not only managing the success of today, you're managing the success of tomorrow. Of course, this then also gets into, organizational change management. So the people side of things is always the biggest roadblock. And a lot of times, I usually always say this. So even when you want to change that you are passionate about, it can still be hard to change. Guess what? Take into account, I'm just going to go buy a brand new vehicle. Well, new vehicles these days, much more complicated than ones 5-10 years ago from my previous one. And so now I have to learn, what's all of these new settings in my car, because maybe I went from a gas to a hybrid, or maybe even an electrical vehicle. Well, guess what? That's a big change in how I have to learn that vehicle and how do I have to drive it and what all the settings are to make the best driving experience for me. That means that my productivity may actually drop, my satisfaction may actually drop until I learn how to drive it the way I want to drive it. The same thing happens when we introduce change within the company. Just because you introduce new technology, you're trying to work on new processes, doesn't mean that people are going to be happy about it, even if they want it. So make sure that you're addressing their concerns. You need to make sure that you're reducing the barriers to their inherent change. You know that they're probably going to resist to some point in time and be like, I just want to go back to the way things were. Well, guess what? We can't go back to the way things were. So let's actually work on, how can we make it better for you so that you can get through the adoption curve with the least amount of distraction to the company and be more productive on the other end. And with that comes making sure that you do the right leadership and communication with all this. Because if you're not doing the right leadership engagement and communication, and the leaders are making sure that this is important, not just for the company, but for them and for their employees, then this makes everything much harder. So I hope this was definitely value to you in seeing that, hey, in order to get value out of AI and help me orchestrate and automate, I need to be doing a good job at implementing technology that starts in PLM, that breaks down the silos between engineering and manufacturing or other departments, and that the data needs to flow between systems continuously and hopefully even in a feedback loop, because we want to be able to consume data and have this response back so that we can react to changes that need to happen due to quality defects or customer service bulletins or whatever it might be. And so that is really where you need to go. I definitely thank you for your time and hope you find this of value. Please always make sure, hey, Element Consulting is here for you to help you solve these big problems. And we have the right experts in place to help guide you through and get you through a lot of the hurdles you're going to face with the technology, with the people, and the process. And so I usually say the technology side of things is the easiest. The people and the process is the hardest. Make sure you have a partner that's on your side for the people and process side. Because while people say they understand it, do they really? Make sure you ask the right questions. And if you're not sure what questions to ask, please find me. I'll make sure to give you some. All right. Thank you very much for your time. Hope you have a good rest of your day.